All right. So, welcome everyone. I'm Rashmi Nagpal. I'm a machine learning engineer by profession and a researcher by passion. And today I'm really excited to share my learnings with all of you on building from data to recommendations. And I'll be covering all the basics to bring all of us on the same page in machine learning domain. So the agenda of the talk firstly is going to be, first of all, for what is artificial intelligence and, what are the building blocks around it and how can we build these recommendation systems. And further on, we'll discuss the overview of the collaborative filtering, that how it plays the roles while we are building the recommendation systems, and what are the challenges / mitigation strategies that we can use whenever we are building all these kind of techniques and tools for recommendation system. And I'll leave you with a bunch of resources towards the end of the talk. So without any further ado, let's begin. So what is an artificial intelligence? It's kind of a big block in which you are training the algorithms which mimics the human behavior. Machine learning is a subset of AI, which is you are training or building some programs, and the model in itself is extracting the patterns from the data set, and it gives you some data-driven decisions around it. So the example over here I've given is spam email detection, and the deep learning, it's a subset of machine learning, which implies that you're extracting the patterns from the huge chunks of the data set and giving, some kind of a real-time data-driven decisions around it. Handwriting recognition is an example of the deep learning. So now I explained you the basics. Let me give you demo around how we can build some machine learning algorithms in the Ruby in itself. So what our use case is going to be that given a housing kind of a data set, which has a lot of features, what I'm implying by features is there are certain columns in the data set, which has, the sales price, location, a neighborhood, or what is the size of the house, whether it's what are the dimensions of the house, and you have to predict the price of the house given on the basis of these features. So let's see how we can do that. So I've already coded like before. So here I'm using the existing packages or the gems, as you won't say, in the in the Ruby in itself. And we have given the data set. I'll show the data set how it looks like. It has like huge, it's a data set which comprises of a lot of features like the square feet, what is the price, again, neighborhood, tax class at present. There are a bunch of features that we are already being given in the data set. So how we are going to build the price prediction model is we are using this linear regression. Again, it's a class, or I would say it's one of the machine learning algorithm behind it. And then first of all, we are reading the data set. Then we are calling this data set like the algorithm on top of the given data set, and we are just running it for 500 epochs. And once we have trained the model, we want to test the model based upon the 1000 square feet or the 2000 square feet, how the model will predict the price of that particular house. Okay, so let's see. Yes. Okay, now we can see in here how the model is training. It's running till 500 epochs, and every epoch you can see the cost, how it is training all around. And if you see the dimension of the house, like if it's 1000 square feet by 2000 square feet, we have to pay around 466K, which is a huge amount. While this is the data set which was based in California. So, coming from that background, well, I'm pretty sure that you can easily find this kind of houses in Italy or maybe like a mansion in here. But okay, so this is how we can train a machine learning model, and that's one of the basic examples. Now I have explained you the basics. Let's go. I want to test the waters. This is one of the very fun activity I really want to do with all of you. So given these images or the faces of the people, I want you to take a minute and think. Think which of these faces are real. I'll just give you all a 1 minute to think around it. Okay, now please raise your hand if you think face A is a real one. Okay, Interesting. Please raise your hand if you think face B is a real face. Excellent. Please raise your hand if you think face C is a real one. Oh, wow. So 80% within the audience have raised the hands for all the faces. None of these faces are real. Okay, so these people, they do not exist on the planet Earth, to say the least. I'm not sure about the extraterrestrial planets. Well, I'm in the astronomy, so I'm not sure about the Andromeda galaxy. Okay, so what is working behind the hoods? It's an application of the deep generative modeling. For example, ChatGPT, DALL-E, these are all the examples of the deep generative modeling. So what is happening is, in an algorithm, you are feeding the data instances. It is synthesizing the brand new data instances which are not existing in the existing data that we are trained the model on. So this is an application of the deep generative modeling, but let's see what is working behind the hoods, how the algorithm or the modeling is happening and building such kind of data instances which look like real ones. So this is a basic neural network, which is the brain behind every AI algorithm you can see. So given an input data set, and then of course the data set input in a sense that it could be numeric, it could be categorical, it could be in any format. Then you're training a machine learning model on top of it. Right now, consider weights, sum and bias, and activation function as a machine learning, as a black box, which comprises of the 3 stages, and then it gives you the output. Output could be any use case that you're trying to build your model on around. Right? So this is the basic example of the neural network. Now, how it works behind the hoods, let's see through an example or application. So this is my Fluffy, my pet dog. I just wanted to build an image recognition on top of my Fluffy, wanted to see whether the algorithm is actually detecting whether this is an image of a dog versus not. So you can see that given an image, it has taken the small pixels. There will be like bunch of other pixels converted to the numeric format, and then you are building a machine learning or an image recognition algorithm on top of it, and it gives you an accuracy, or I would say a confidence that, okay, with 92% confidence, this is an image of a dog, or maybe like 8% confident, it's an image of a cat. Right? So that's how the machine learning or the basic neural networks is working behind the pictures. Now, if I want to deploy image recognition or any machine learning use case in the real world, how the stages look like, what are the building blocks behind it? You can see over here, there are 3 main pillars. The first is the build stage, next is the deployment stage, and the other one is the monitoring phase. So what happens in the build stage is, you have the data ingestion, then you are training the model on top of it and understanding how the model is going to test, because you want to reiterate the process, right? And once you are very much satisfied with it, you go with the deployment stage. Package the model, just test in a real world example, and then you keep on monitoring it. And if the model, let's say you have trained the model back in 2019, you want to see how the model is performing over the years. So that's why you circle back to the build stage, and that's why you can see an arrow which is circling back from monitoring to the build stage. So this is how the entire pipeline of the machine learning looks like. But wait a minute, we are here to build the recommendation systems. So let's see. So what happens in the recommendation system is, let's say there are 2 people who really like the pizza and the salads. Then whatever the application or the system is going to be, they will recommend you, or maybe like having a piece of the Coke, or maybe like this kind of an item within the entire entities that you have ordering. That could be a possibility. Basically, it improves the churning rate / I would say more and more e-commerce websites are taking in. A very example, or we can see in the day-to-day life, is a Spotify example. Like recently, I'm just interested in this metal music. So the other day, I was just listening to the Pawn of Osiris, and then it started recommending me, you know what, maybe you can like some other piece of the metal band. So that's how the recommendation systems are working in. Netflix, we all see the Netflix, right? Oh, if I have seen a particular movie, then it will recommend, there are certain movies which you can see, which are very much similar to how, this movie is on the basis of your taste or your particular genre of the movie that you want to watch. Similarly, the e-commerce website, for example, the Amazon. So I was just actually, the other day, I was looking in for disappointing affirmations, which is one of the famous books, how you need to unfollow your dreams. Though the title itself sounds controversial, but it's a highly recommended book. Then you can see that how the Amazon behind the hood started recommending me the books which are on similar taste as to mine. So Amazon, Spotify, Netflix, all these kind of entertainment music industries, they are always, emphasizing these or working behind the hoods is the recommendation system. And did you know that on an average, an intelligent recommendation system delivers around 23% approximately kind of a conversion rates for the web products, and it was being reported by the NVIDIA in itself. But, we have seen so many use cases of the recommendation system. But what is the rationale or the logic behind how it works? So a very high level I'll give you is on the basis of the user preferences, whether it could be the explicit or an implicit. For example, you must have seen a small, the drop-down box which will come. Was this previous video favorable? Was it interested to you? So that's how all these, websites are collecting users' data, and then they are recommending on top of it. So you are passing in the user preferences, and then in the recommendation system in itself, it is providing you the recommendations or whatever your preferences could be. And there are like two main categories of it. The first is the collaborative filtering, the other is the content-based filtering. I'll give the demo of both of these techniques, but first of all, we need to understand what is the collaborative filtering and what is the content-based filtering. So in the collaborative filtering is, let's say me and my brother, we actually watch a particular movie, then it is going to recommend on the basis of what our taste buds are going to be like. So in a way, it is collecting like in a collaboration of the two users. Whatever the two users have watched a movie, maybe they're recommending on the similar taste on that. And what happens in the content-based filtering is, let's say a particular user has seen a particular movie, then it is actually checking on the basis of, why this movie this particular user has taken, and then it will recommend on the basis of the previous history of the movies that this particular user has seen. So that is how the content-based filtering is coming in, and that it might be recommending to some other person as well. Netflix actually uses both of these. They use like the hybrid algorithm behind the hoods whenever they're recommending any kind of, the movie or the shows or the dramas or whatever we really wanted to see. So let's see first. Okay, so the recommendation systems, how they work behind the hoods, some mathematics is there, but I'll explain on a very high level so that it becomes intuitive for all of us to grasp and understand. So given the users and the items you can see, let's say an item could be a movie, right? There are like three users, Ted, Carol, and Bob, and all of the, you can see the Ted, Carol, and Bob, they all like the movie B. I'm just giving an example of the items as the movies right now, which could be anything. Maybe like it could be a food item or it could be anything else. So you want to suggest whether the movie C is being liked by the Bob versus not. So that's why I use like least squares algorithm, which is also kind of for defining the differences between, the cosine similarity. Given the two data sets or the text vectors, you find the distance, and the lesser the distance, it implies that the more favorable the person is going to like a particular thing. So Bob will highly likely love the movie C. So that's how it is happening behind the scenes. Given an item and the user, so you do the matrix multiplication. So this alternating least square algorithm is working behind the hoods. Basically, it's just doing the matrix multiplication of the users and the items, and then it fills out this kind of a matrix, which is a sparse at the moment. So that's how this matrix multiplication or recommendation system works. So let's see first an example. Here I've given like multiple users, and all of these users are given a certain rating, and those ratings are from the 1 to 5. And there are like 6 items around it. You can see this is a sparse matrix. User 1 likes the item 1, 5, and the user 1 again likes the item 2 at 3. But we don't know whether the user 1 likes the item 4, 5, or 6. So we need to fill a lot of this information. So let's see how we can do. So this is what the data that I have, and that's what the table I showed in the slide. That is what our goal is. You need to understand, for a particular user, what are the recommendation of the fun for the user 1 and what it particularly likes. So let's see. What I'm doing right now is I'm just calculating the cosine similarities, and then on top of it, I'm finding the similar users who particularly like. Maybe the user 1 has a similar taste as the user 2. And on the basis of it, it will do the recommendation. So it's working the ALS algorithm behind the scenes. So you can see for the user 1, there are like the 2 items. It has highlighted the user, which is the item 4 and 5, and with a certain value or a score you can see. And the scores could range from 1 to 5. I've not normalized it, but we can also do the normalization around it. And if you want to see for which particular user, let's say, okay, so this user 1 has been mapped to the different other users, like the other users which were given as 2, 3, and 4. Similarly, if we want to find for the other users, we can definitely change, we are just again passing in the recommend items, a different user altogether, and we can see how the model is going to interpret and give you the corresponding recommendation for this. Okay, so next example I wanted to show you for is the books recommendation. Given a book name, can you recommend the similar books on the basis of the genre or maybe like the, the style around it? So let's do that. So I have already some data for this book recommendation, and I am actually passing in, okay, this is the universe. I'm much more into the astronomy, so I will be giving like so many examples around it. So I like this book, which is the universe, and let's see whether our algorithm is able to give and suggest recommendations around the similar book. Okay, so you can see that the books which has given, the recommendation model has given the brief history of time, why the universe is the way it is, a man on the moon, and the history of the space exploration. So you can see that the similar taste of the book has been given in the model by itself and what is the corresponding recommendation that it has given, right? So that's how we can build so the first example was of the collaborative. This one is an example of the content base because I like a particular content and therefore it has given me an example. Okay, maybe the universe is a book that you like the most and therefore you would like these other possible books, which is the space trilogy or maybe the space odyssey, these kind of different books around it. So let's come back to our slides. There are like bunch of challenges whenever we are building the recommendation system. The first is the cold start problem. So actually Netflix also faces this problem when they initially started out because there were like no users, no history. You don't know whether a particular user will like this kind of a movie versus not. So that is when the e-commerce website started facing an issue of the cold start problem. That is the content that there is no existing content or the history of the user. Therefore, the model needs to have it in order to predict what could be the future possibilities. And the next is the sparsity. So there are, of course, a lot of algorithms which helps in dealing with the sparsity, that when there is less number of items in the data in itself, how we can actually provide the ratings. And scalability is also an issue, when you need like a lot of resources, intensive resources, because you want to train deep neural networks or, all these kind of large language models. So scalability is also one such potential reason that, what are the challenges in terms of the recommendation system. Diversity is equally important. So what I meant by diversity is diversity within the data. The more the diverse data is, the better the recommendation model is going to perform. If the data is, skewed or the distribution is not fair, of course, the recommendation model is not going to give the better prediction values. As we say, garbage in, garbage out, right? So if you're putting in the garbage or the trash of the data inside your recommendation model, therefore the model is going to give the trash kind of values. So definitely you need like the good data, which is clean out, all the removing of the outliers. So let's see the ways how we can mitigate all these challenges in the recommendation system. Again, just circling back to what I was just saying before, you need to have a good correlate of the data. We don't want the data which is skewed or highly skewed towards one particular class so that the model is not going to learn and predict. So that's why we need to remove and pre-process the data, remove the outliers in the data, and in order to tune our hyperparameters around it. Using the hybrid approaches, not just combining, not just having the collaborative or the content, but just the hybrid or ensembling of the modeling per se. And you can use a lot of data augmentation techniques or feature engineering. The model selection also plays like a really important role, which is kind of a brainchild, how your recommendation system is going to work behind the hoods. So model selection plays a role. The next is the privacy preserving techniques. Sometimes user would be hesitant in order to share the PII, personally identified information, right? So you can use the privacy preserving techniques. Federated learning is one such technique. Differential privacy, these are different techniques that you can use whenever you are building all these kind of recommendation systems. In nutshell, what is the importance? What is the behind? So what is the rationale of using a recommendation system and why we need it? First of all is we want to leverage the data-driven insights in order to make the better decisions whenever we are building all these recommendation systems. And we want to optimize the resource allocation and personalize user experiences. The seamless experience that we face on the Netflix is all because we want these intelligent systems to use our data in order to make the good data-driven decisions around it. And we also need like the continuous innovation. For example, the other day I was having a chat with one of the speakers, and he suggested, you need to always enhance the existing code that you have, because that's how you optimize the model. You can't have the model which is stale or trained on a data set which is like years ago, because that model is not going to learn in the next years, right, in the future. So always innovate. Look for the ways so that you can innovate in the recommendation systems. It could be enhancing the existing code base or just optimizing or using some of the techniques which are like everyday releasing out, especially in the LLM space. And we also need to integrate the ethical consideration and privacy preserving techniques, which I have mentioned before, because we want to protect the user's data, and we also want to ensure that we are responsibly using the recommendation systems. These are like bunch of resources which I will definitely vouch out for. The first is a blog, which is a really good blog. The next is the deep learning course in order to understand the basics, what is deep learning and how you can use Accelerate. And it's like open courseware, so you can definitely use it. The articles is also like Code with a Jason is one of my favorite persons, so you definitely should read those articles. Thank you so much.